Hello class. This lesson's about standard derivative 0.6, which is I can take higher order derivatives of functions and apply it to the real world application of position, velocity, and acceleration. Higher order derivatives, what it means is the second derivative of a function, and it's the slope of the first derivative of the function. For example, here's a graph f of x, and let's just say sketch the graph of f prime of x, which means the derivative, and f prime prime or f double prime of x. So here, let's say here's the function, and we're going to call this f of x. Let me just write it on here. Let's just say that's f of x. Now let's just say I wanted to find the slope of this. Do you agree in this area right here, the slope is positive? And it's here, it's really steep, then it's get less steep, then less steep, then less steep, then less steep, and then now the slope is 0. So what I'm going to do, basically, the slope here is basically, it's positive but going smaller and smaller and smaller and then getting towards 0. So it's almost like a straight line. So the slope here is really, really high, which is here. And then here it gets less steep, less steep, less steep. So here it's less positive, less positive, positive. And at the top my slope is 0, so that's why it's 0. Here my slope is negative. It's slightly negative. Then as I get further and further, it's very, very, very negative. So that looks like this. That is the line of f prime of x. And I'll write that here. Now, if I want to find f double prime of x, I want to know what the slope of this is. Do you see the slope is like the slope is just one regular slope, and it goes for the whole function? Let's just call this like -2. The slope here is like, let's just say -2, or it's -5. I can't really measure it. Well, actually, here, look. I go down 4 and over 2, so I have a slope of -2 here. So the slope is -2 here, the slope is -2 here, the slope is -2 everywhere. So f double prime looks like this. So what you have is, if you have a parabola, its derivative tends to be a linear or a line. And then the derivative of a line is always the same throughout, so that's why it's always a flat line. This is an example of what they call higher order derivatives. So the notation, as I told you earlier, is f double prime of x. And then for the rate of change, or the way you see it, instead of dy dx, they call it d squared y dx squared. The third derivative is f triple prime d to the third y dx third prime. So these are just notations, and then also f of n, like whatever prime it is, and then dny over dx and y. These are just the definitions of derivative. So what I want you to practice, or what we're going to do is an examples, is how do you find the second derivative or higher order derivatives of certain functions. So these ones, let's say find the second derivative. So here's my function, which means y prime will be, this is going to be 15x squared, because that's the derivative, 5 times 3, and then I subtracted 1, plus cosine x, that's the derivative of sine, minus 1, which is right here, minus 1. And this 3 over x, some of you might say, oh, that's the quotient rule. But I can also rewrite that 3 over x means the exact same thing as 3x to the -1. And the derivative of that is minus 3x to the -2. So that is y prime. The problem is that it doesn't want the first derivative. This problem wants the second derivative. So I will write, let me just zoom in here real quick, y double prime, meaning second derivative, 15x squared, that derivative is 30x. Cosine, you know the derivative of cosine is negative sine x. Minus 1, the derivative of -1 is just 0. And then I have this minus 3x to the -2 power. That becomes plus 6x to the -3. So that is the derivative, second derivative of the function that they gave us. So if you're comfortable taking the second derivative is just doing the exact same thing one more time. Here's a little bit of a tougher one. It looks like a couple of rules are in play here. I have a product rule and I have a chain rule. I have two terms, 3x, which is multiplied by cosine 2x. And inside of cosine, I have a function 2x. So I'm going to do the product rule. The product rule says take the derivative of the first one, which is 3. Leave the second one alone. Plus, leave the first one alone. And then times the derivative of the second one. This is chain rule. So it's going to be the outside function, which is negative sine. Then I'll leave the inside function alone, times the derivative of the inside function, which is 2. So if I were to simplify this, this is just 3 cosine 2x plus, oh sorry. There's a minus now, so I have a minus right here. It's going to be minus 6x sine 2x. And that's nice, except for this problem wants the second derivative. Okay, so let's find the second derivative. And what you might not like about this second derivative is you may notice that I have two functions now. The original problem was just one. Here I have a 3 cosine 2x. Remember, every time you have a coefficient, I can just move that to the side and multiply it back in later. And we already found the derivative of cosine 2x in the last problem. Remember in the beginning, we found the derivative of cosine 2x to be negative 2 sine 2x. Remember that was the derivative of cosine 2x? So I have my 3, which I'm leaving out. And then I already found the derivative of cosine 2x, which was negative 2 sine 2x. Minus, and now I have another product chain rule combination here. So it's going to be, just to make this quick, 6 sine 2x plus 6x, I'm running out of space here, 6x, oh, what do you know, I have all the space, plus 6x cosine 2x times 2. And that's, remember, that's the chain rule. So the derivative of sine is cosine, so cosine 2x times the derivative of the inside, that's how I got 2. Now let's simplify this all out. I'm going to get a negative 6 sine 2x, that's the first term. On the inside of my brackets, I'm going to simplify to 6 sine 2x. And then plus 12x cosine 2x. Okay. And now I'm just going to simplify this all out. I have this minus sign. I'm going to distribute to the rest of them. 6 sine 2x minus 6 sine 2x minus 12x cosine 2x. And that's supposed to be a minus. And now combining this all, see I have a minus 6 sine 2x and I have another minus 6 sine 2x. So that gives me minus 12 sine 2x minus 12x cosine 2x. And that is the second derivative of the function. Complicated, yes. Tedious, yes. But I think you guys understand the process pretty well. Now, at the bottom of your page, they say find higher order derivatives, where they want me to find like the 4th derivative or the 6th derivative of a function. Just don't worry about that stuff. You just know that there is possibilities for more, but we're not going to do that, for example. The biggest question, and as we get closer and closer to this, you know, some of you might be getting tired of derivatives and wondering why we're doing this. So now, in this next chapter, we're actually going to talk about all the applications for derivatives, where they use it in the real world. And I'm going to give you sort of a sneak preview. They use it for, and some of you have taken physics or are taking physics, they use this to talk about position, velocity, and acceleration. So at the way beginning of the year, we talked about Usain Bolt and his running. Again, they can use derivatives to sort of pinpoint his exact speed at certain locations. In addition, because you know second derivatives, you can also find his acceleration at certain points. So if I'm going to go to the next page, and this is how they're related. Velocity is the rate of change of position with respect to time. Acceleration, its definition is the rate of change of velocity with respect to time. Hence, the acceleration function can be found by taking the derivative of the velocity function. So in other words, if the position function is, say, like s, velocity is a derivative of s. Acceleration is the derivative of v, or the double derivative or the second derivative of the position function. And just as a main definition that you need to know, if anybody asks you for speed, speed is the absolute value of velocity. So speed is never negative, velocity can be negative. So if I say how fast are you going, or what's your speed, you could say 10 miles per hour. Your speed cannot be negative 10 miles per hour. But I could say your velocity is negative 10 miles per hour. That's the difference between speed and velocity. Velocity can have a plus or minus sign. So let's say, for example, we'll look at this first one. It says we have a particle and its position function is 2t to the third power minus 21t squared plus 60t plus 3, where t is in seconds. Determine the position, velocity, speed, and acceleration of the particle at t equals 3. So first thing I'm going to do is I'm going to find the position. To find the position, all I'm going to do is plug in 3. Because it says find at t equals 3. So if I plug in 3, I'm going to get 2, 3 to the third power, minus 21, 3 to the second power, plus 60 times 3, plus 3. Okay. Then I'm going to multiply this out. I'm going to get 3 to the third power is 27. 27 times 2 is 54. 3 squared is 9. 21 times 9 is 189. Plus 180 plus 3. If I add this all up, I get 54. I'm going to get a minus 9, so it's going to be 45 plus 3. I get 48. And remember, for all these problems, you need to have units. So this answer is going to be 48. And they didn't even give me any units, so I'll just say 48 units. Okay. And usually they give you some sort of units like miles or inches or something. Now, it's going to say what's the speed. To find the speed, remember they gave us the position. So what I'm going to do is I'm going to take the derivative of this and get the speed and velocity. So I'm going to erase this, so hopefully you can pause this and write this down if you need to. And now let's find the velocity and speed. So I'll take the derivative. So I'm going to write this as v for velocity, which is the first derivative of what they gave us. So it's going to be 6t squared minus 42t plus 60. So that is the derivative of this function right here. Now, it wants the speed and velocity at 3, so I will now plug in 3 and find out its velocity. Well, to make this quick, 3 squared is 9. 9 times 6 is 54. 42 times 3 is 126 plus 60. So adding these all together, 60 plus 54 is 114. So I'm going to get a negative 12. And again, I need units. They didn't give me units, so I'm just going to say units per. And in this particular question, they give it to me in seconds. So it's units per second. Negative 12 units per second. Now, question for you. Is that velocity or is that speed? Yeah, it's velocity. And you know it's velocity because it has a negative, it's negative. It has a negative sign. Now the question says velocity and speed. Could they be the same thing? Yeah. So if this answer was 12 units per second, the velocity could be 12 and the speed can be 12. In this particular case, it says that we found the velocity to be negative 12. So that tells me the speed, again, is the absolute value. The speed is 12 units per second. So this one is speed, and this one is velocity. Again, they could be the same, but in this particular case, because I got a negative number, that has to be velocity, and the speed has to be positive, because speed cannot be negative. Speed always has to be positive. So that's all the time I have. We're going to do some more practice in class, but hopefully you guys get the point of how to take the second derivative and how to apply it to a problem like this one. If you have any questions, again, write it down in the questions below, and then I'll see you guys in class. Take care.